So for this question, we have ABCD to be a parallelogram. The side BC is extended to F, and the line AF meets DC at the point E. Now, first part, we want to show that AED and FEC are similar triangles. Okay, so let me highlight the triangles here so that we can really observe them to take a better look. FEC is in blue and AED is in red. Now remember that one of the things that I share with you is that when the diagram has a lot of parallel lines, this allows us to take on a very diverse various good set of properties that we have learned in junior high 1, right? So a lot of things that comes very nice with parallel lines, things like alternate angles, corresponding angles, interior angles. So if I look at AED and FEC, the first thing that will glare at you is probably these two angles which are equal. Right? So if they are parallel lines, it's quite easy to find pairs of angles that are equal. So the first one here, in part 1, angle AED is equals to angle CEF, right? And basically this we will use vertically opposite angles, as well as the next set of angles that you can probably use is angle EFC as well as angle DAE. Now angle EFC comparing to angle EAD, these two are also equal because of alternate angles. And remember, when you write down alternate angles, any property that you use that deals with parallel lines, remember to write down the sponsors, okay, or the parallel lines which provides for this property to happen, to give us a due recognition for the parallel lines, okay, that allows this to happen. So if you look at the red and the blue triangle now, we can see that triangle AED is similar to triangle FEC, and the reason none other is by saying that two pairs of corresponding angles are equal. Alright, so next let's look at part 2. Now given that ED to EC is 4:3 and AD is equals to 12, okay, so let's look at ED. Now ED here takes on 4 units, AD takes on EC takes on 3 units, and AD is 12 cm. Once we have the earlier result of AED to FEC, remember that one of the things that I really like to do is once you have that, you write down the corresponding sides. Alright, remember they must be in the same order. First two vertex over FE is the same as AD over FC is the same as ED over EC. These are corresponding sides of similar triangles, have the same ratio, and after which you can actually enter to fill in the blanks. Now ED over EC is 4:3. It will tell you that ED over EC has a ratio fraction in the form of a fraction which is 4/3. Now you know that AD is 12. Alright, so here it seems like what I can find is FC, but I'm asked to find BF. Right, so if you observe BF here, one of the things you can see that because we are looking at a parallelogram, we can also conclude that BC is just equals to AD, right? This is because this is just a properties of a parallelogram. Okay, so because of that, I can also say that BF can be found by is the same as instead of BC plus CF, we can also say that it's the same as AD plus CF. Alright, so over here, FC over here is what I can find looking at this fraction. 12 over FC is equals to 4 over 3. This means that if I cross multiply, I have 4 times FC equals to 36. And FC is equals to 36 over 4, which is 9. Okay, so I know that FC is 9 cm. At the same time, I know that AD is 12, which is equals to BC. That allows me to conclude that my BF, which is the same as BC plus AD plus CF, will be 12 plus 9, and it turns out to be 21 cm. So that is part 2. I next go on to part 3, and I'm asked to find the aerial ratio of FCE to FCA. Okay, so let me use a different color ink. FCE is the one in blue over FCA. So FCA is the one in green that I'm going to put on the outside. So if you can see here, right, just observe at these two triangles, the green and the blue, you can see that these triangles are actually triangles that have the same height. If we were to just rotate it a bit, and I put a red dotted line here, the blue and the green triangle can both take on this red dotted line as the height. Now, because it's such a beautiful relationship, that these two triangles have the same height, I want you to note that, this is what they are testing here. We are having the triangles with the same height. With that, what you will see is just take on the ratio of the area. Because they have the same height, then the area is just the ratio of the base. The area of triangle FCE over the area of triangle FCA will just be the ratio of the base, okay, which is EF over AE. Okay, now this may seem very elusive now, but if you consider the good results of what you have done earlier, you can see that EF over AE can be found here. Right? If AE over FE is 4 over 3, it's simply FCA. Oh, sorry, it shouldn't be AE, it should be AF. My bad, my bad. This is AF, right? Because we're looking at the green triangle, right? Which is the same as EF over AE plus EF, and basically the ratio here is 3:4 as well, because of the result from earlier, right? AE is 4 units, FE is 3 units. So FE, if you put 3 units, AE to be 4 units, EF to be 3 units, then you just have the answer to be 3 over 7. Okay. Now let's go to part 4. Part 3B. Right? This is part 3A earlier, and now we'll go to part 3B. The area of triangle FCE over the area of triangle ABCD. Alright? So it looks very, very daunting, but if we go step by step, alright, first consider that earlier on when we look at the different triangles, right, if we look at the one in FCE here, it represents 3 units, and how FCA represents 7 units, I can say that now if the area of triangle FCE to the area of triangle FCA, this is basically 3 is 2. Not FCA, ECA, my bad. ECA, do note that ECA is over here. ECA is over here. Let me put it in yellow. ECA is over here. ECA is in yellow, and FCE is in blue. Right, the ratio is 3:4. Okay, because this is 3 over 7. Therefore, this is 3 unit. This is 4 unit. I'm just going to use a circle to represent a number with a circle here to represent the area ratio. This 3, this 4 unit. At the same time, you know that if I compare FCE earlier on to AED, right? Earlier on, if I compare FCE to area AED, yeah. Okay, so let me use red color here, AED. Comparing these two, right? Earlier, this is nothing but two similar triangles. So the area of FCE to AED, because these two are similar, this is 9/12 square. FCE to ADE, right? It's basically a 9/12, which is FCE to AED. Now this AED, yeah. So AE is basically, because they're similar, the ratio is 9 here. Okay, it's like 9/12 square, right? Because I look at this, which is the same as 3/4 square, which is the same as 9/16. So this is 9:16, right? So FCE to AED is 9:16 because of the fact that it's 3/4 square, 9/12 square, because these two triangles are similar. So let me just write down here. This means that, if I want to really compare all three side by side, this has to be the same unit of measurement. So 3, what I can do, I multiply this by 3. I multiply this by 3 as well. Then I can say that if I were to compare all on the same level, same unit measurement, then FCE represents 9 units, ECA represents 12, and AED represents 16. Okay, so let me just readjust this. ECA represents 12, FCE represents 9, AED represents 16 units. Okay, so what you can see is that why is it I'm so interested in finding all of them separately is because when you combine the red and the yellow, you will see that they actually give you half the parallelogram. Okay, so look at the red and the yellow. Okay, so if you look at the red and the yellow, all together, it adds up to 28 units. 28 times 2, that means that the parallelogram ABCD represents 56 units. Now remember that the area of AED added to the area of AEC is basically half of the parallelogram ABCD. Right? So it means that ABCD here can be represented by 2 times 12 plus 16 units, which is 56 units. Okay, in all the same unit of measurement, FCE is represented by 9, the parallelogram is represented by 56. So therefore, the area of triangle FCE over the area of the parallelogram ABCD would be 9/56. Thank you.